Forget small towns and big cities, we're talking about cosmic cities. Vast islands of billions of stars called galaxies. We're not just tourists. We're residents of one, the Milky Way. But what makes our spiral home different from the cosmic ovals and chaotic clouds out there? Get ready to explore the different neighborhoods of the universe. So what are these cosmic shapes? Astronomers classify them into three main types based on their appearance or morphology: spiral, elliptical, and irregular. Spiral galaxies. These are the beautiful pinwheels, making up about 60% of observed galaxies. They feature a bright central bulge and spectacular flat spiral arms where lots of gas and dust exist. This gas and dust are the fuel for star birth, so spiral arms are often bright blue with young, hot stars. Our own Milky Way is a barred spiral, with a straight bar of stars across the center. Elliptical galaxies. These are smooth oval or spherical shapes ranging from nearly perfectly round, E0, to highly stretched, E7. They contain mostly older, redder stars and have very little gas or dust left. This means they are almost entirely done forming new stars, earning them the nickname red and dead. They are often found in crowded galaxy clusters. Irregular galaxies. These are the cosmic oddballs with no defined structure. They are often smaller and contain a mix of old and new stars. Their chaotic shape is usually a result of intense gravitational forces from other, larger galaxies, like a passing car distorting a cloud of smoke. Let's break down the anatomy of a galaxy, using a spiral as our example. It has four key parts. First, the central bulge. This is a dense, football-shaped concentration of stars, gas, and dust at the very core. Second, the disk. This is the flat, rotating part where the spiral arms are located. Most of the young stars, gas, and dust reside here. Stars in the disk orbit the center in a relatively organized circular path. Third, the spiral arms. These are not fixed structures, but rather areas of slightly higher density, like a traffic jam on a highway. As stars and gas move through these jams, the gas compresses, triggering the birth of new stars, which is why the arms are so bright. Fourth, the halo. This is a huge, sparsely populated, spherical region that surrounds the disk and bulge, containing very old stars and ancient star clusters called globular clusters. Now for the million-star question. What is the glue that holds a galaxy together? You might think it's the gravity from all the visible stars, gas, and the central black hole. And while gravity is the force, there's a problem. When astronomers measure how fast stars orbit the center of a galaxy, they are moving too fast. The gravity from all the visible matter is not strong enough to keep them from flying out into space. This leads us to the biggest component of a galaxy: dark matter. We can't see it. It doesn't emit or absorb light, but we know it's there because of its immense gravitational pull. Galaxies are surrounded by a huge, invisible dark matter halo that provides the majority of the mass and the necessary gravity to keep billions of stars locked in their orbits. In fact, for a typical galaxy, only about 5% of its mass is the visible stuff. Dark matter is the gravitational skeleton of every galaxy. So, from the beautiful spirals of star birth to the ancient elliptical ovals, every galaxy is a cosmic city, built by visible matter but anchored by an invisible giant.